Hello friends, this video on alcohol, phenol and ether part 21 is brought to you by examfear.com. No more fear from exam. Now we'll see the uses of phenol. Phenols are used for manufacturing of plastic. It is also used to prepare explosive, dyes, antiseptics. It is used to produce nylons. There are so many properties, uses of phenol. Now we'll talk about the properties of phenol. We'll talk about physical state, boiling point, solubility and density. We'll talk about these things for phenols. Let's talk about the physical state. This is how phenol looks. So phenols are generally solid. Some are liquid but generally solid with lower melting points, and they are colorless. You can see this is phenol. If you talk about the boiling point, so if we talk about the general rule, the boiling point increase with increase in number of carbon atoms. That is, you increase the molecular mass, the boiling point increase. The second is the boiling point of phenols are generally higher when you compare with other compounds of the comparable molecular mass, and that is because of the intermolecular hydrogen bonding. We will talk about this in the next few slides. We talk about solubility. Phenols are sparingly soluble due to hydrogen bond in water, but they are easily soluble in alcohol and ethers. The solubility decrease with increase in size of arrival. The same trend we have seen for the alcohol, same trend here, right? And several lower molecular mass alcohols are, in fact, phenols are miscible in water in all proportions. So if we have lower molecular mass of phenol, it will be more soluble, right? If I have higher molecular mass phenol, it will be less soluble. We'll talk about the effect of substituting groups on the phenol properties. Here we'll talk about intermolecular force. So it says that orthonitrophenol has lower BP and is less soluble than paranitrophenol. Let's first draw ortho and paranitrophenol. This is my orthonitrophenol. Here if you see, there is a bond between, it's this intramolecular hydrogen bond, right? And if you talk about the para one, intermolecular is pretty impossible, but intramolecular is possible. It can form a hydrogen bond with other neighboring compounds. If you see here, this is possible, right? So here we have intramolecular H bond, and here I have intramolecular. So if you are confused between inter and intra, think about the word internet. Internet means you can see the websites hosted in other servers. Example, you are seeing this in YouTube or somewhere from your home. We talk about intramolecular. Then let's suppose you're in college and you have access to your website, college websites only from college. That is the intranet, and this is the internet. So you can just make out the difference between intra and inter. Right? So now if you see, this guy has intermolecular hydrogen bonding. It has intramolecular hydrogen bonding, right? So it will not form intermolecular hydrogen bonding. So this guy, if you see, has low BP and less soluble also, because these guys are not very strong. But these guys, they form something like a web, right? This is attached, something like that. So it's very strong. Since they are very strong, they have high BP and they are more soluble also. Just understand that this is like people fighting between themselves only, right? So this unit is strong, but this unit is a very small unit, right? So in this case, this unit as is not small, but the overall thing is small. So when you talk about the boiling point or the melting point, you talk about the overall. So in this glass of, let's suppose, beaker, you have millions of these compounds, right? So when you talk about the boiling point, you don't talk about the boiling point of this particular compound. You talk about the boiling point of the whole millions of phenols you have in this, right? So when the interrelationship between these are strong, right? They have a big web structure. Nobody can disturb them easily. So they'll have high boiling point and they'll be easily soluble. But when they are all individual pieces, they are not very much united, right? So they'll have low boiling point. Any small amount of heat can disturb their condition. Hope you understand. Just understand the logic, right? So we can talk about the boiling point and melting point. You don't talk about the boiling and melting point of a particular one individual compound, right? Or atom or molecule. You talk about millions and billions of molecules in the beaker. So if there is a strong force of attraction among these phenols, small amount of heat can't disturb them. That means you need greater amount of heat to disturb them. That's why they have higher boiling point. These guys, if you see, they don't care about their neighbors. They don't care about their friends, right? Other phenols. So the force of attraction between them is not that strong, right? So you see the overall phenols, they are all divided, and a small amount of heat can disturb them.
Correct.
Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.